All right, so example 5 says, solve the differential equation dy by dx plus y tan x is equal to sine x when x is 0, y is 1. All right, first of all, it is already of the form dy by dx plus py is equal to q. So p is equal to the tangent of x, or tan x, and the integral of p would be equal to, the integral of p with respect to x is equal to the integral of tan x dx. And if memory serves me right, this is ln sec x. Q is equal to sine x. So our solution would be y e, the integral of p dx, is equal to the integral of q e, the integral of p dx. So this would be y e ln sec x is equal to the integral of q, which is what? Sine x, e ln x dx. Sorry, it's not ln x, it's ln sec x. But ln sec x, e to the ln sec x is just sec x. So this is y sec x is equal to the integral of sine x sec x dx. Sec x is what? 1 over cos. So let us say that this is y over cos x is equal to the integral of sine x over cos x dx. But sine x over cos x is just what? Tan x. So y over cos x would be equal to ln sec x plus c, the constant of integration. So y would be equal to cos x ln sec x plus cos x c being the constant of integration. Now we're given the values of x, and y, so that we can find c. We're told that x is 0 when y is 1. So now we can get this to be 1 is equal to the cosine of 0, ln sec 0, plus the cosine of 0, c. This is 1. The cosine of 0 is 1. Ln sec 0. I think sec 0 is also 1 plus 1 times c. But ln 1 is 0. So 1 would be equal to, this is 0 plus c. So c is 1. So c is 1. And if c is 1, y is equal to cos x ln sec x plus c cos x. C is 1, so it's just cos x. All right, so let's have a go at example 6. Example 6 says, find the general solution of the differential equation x dy by dx plus 4y is equal to x plus 1. Hence, find the solution when x is 2 and y is 1. So we're to find the general solution and then find the solution when x is 2 and y is 1. First, let's get this into the proper form by dividing the entire equation by x. We're going to end up with dy by dx plus 4 over xy is equal to x plus 1 over x. So now my p is 4 over x, and the integral of p with respect to x would be the integral of 4 over x with respect to x, which essentially is 4 ln x, or we could say ln x to the 4th power. Q is equal to x plus 1 over x. And our solution is going to be y e, the integral of p dx, which is equal to the integral of q e, the integral of p dx dx. This becomes x plus 1 over x times e ln x to the 4th power. But e ln x to the 4th power, so this is y e ln x to the 4th power. E ln x to the 4th power is x to the 4, so y x to the 4th power is equal to x plus 1 over x times x to the 4th power. Oh, sorry, don't forget the integral. Integral dx dx. All right, so this is x now to the 3rd. So y x to the 4th is equal to the integral of x to the 3rd, x plus 1 dx. All right, I can expand and say that this is the integral of x to the 4th plus x to the 3rd dx. If I integrate, I'm going to get 1/5 x to the 5th plus 1/4 x to the 4 plus c, the constant of integration. All right, remember when x is 2, y is 1. So let's put those in so that we can find c. When x is 2, y is 1. So 1, 2 to the 4th power is equal to 1 over 5, 2 to the 5th power plus 1 over 4, 2 to the 4th power plus c. 2 to the 4th power, I think, is 16. 2 to the 5th power would be 32. And then we have what? 16 over 4 plus c. So it looks like c would be equal to 16 minus 4 minus 32 over 5. That's 12 minus 32 over 5. That would be, it looks like 28 over 5. Because 12 is the same as saying 60 over 5. 60 over 5 minus 32 over 5 would be 28 over 5. So y, x to the 4th, is equal to 1/5. X to the 5th plus a quarter, x to the 4th plus c, which is 28 over 5. And of course, if I wanted to, I could just divide the entire equation by x to the 4th. In fact, let's just do it. Y is equal to 1/5 x plus a quarter plus 28 over 5 x to the 4th.